Hello, today I'm going to be making a sourdough starter and Hello, today I'm going to be making a sourdough starter and using the discard to make some delicious banana bread. We'll begin with the starter, which is a 7-day process. The equipment for making the starter will be a glass jar, 1 quart, with a loose fitting lid for the fermentation to take place in, a digital full scale, and an instant read thermometer for measurements. I know chemistry is usually done in Celsius, but food recipes seem to favor Fahrenheit, so I'll be using Fahrenheit today. A spatula silicone is preferred for mixing, and the ingredients I'll be using is organic unbleached whole grain dark rye flour, unbleached organic all-purpose flour, and water. Using unbleached flour is crucial. Without it, fermentation will not occur properly. To clarify, starter is not the dough, but the levain. Levain is French for starter, which is a mix of water and flour that has been converted into a leaving agent through the process of fermentation. By fermenting water and flour, growing good bacteria called lactobacilli and wild yeast. The bacteria's main job is to turn the starter into an acidic environment. Acidity contributes to the sour flavor of the bread and prevents bad bacteria from taking hold. The wild yeast is grown because commercial yeast can't survive in the acidic environment. Wild yeast and the good bacteria gives off carbon dioxide, which contributes to the structure and rise of the bread. The record bacteria also gives off carbon dioxide as a byproduct. This starter replaces the cheap instant commercialized yeast by using wild yeast accumulated from the flour instead of resulting in a better look and a better control for taste. There are 2 main acids produced in the sourdough, lactic acid and acetic acid. Acetic acid is the acid that gives sourdough much of its tang. Giving acetic acid producing organism optimal conditions to thrive and multiply will produce a more tangy finished product. Producing more tang is achieved by adjusting the starter by maintaining it at a lower hydration level, using a higher ratio of flour to water. Acetic acid is produced more abundantly in a dry environment, while lactic acid producing organisms seem to thrive in a wet environment. Using whole grain flours, which the acid-producing bacteria utilize the best. Storing sourdough starter in a hot location, especially in the beginning, could cause bad bacteria to grow, which would overrun the good bacteria, ruining the mixture. A range of 70 to 75 degrees Fahrenheit is a good temperature. Once the sourdough starter is mature, bubbling and rising and falling will occur. Cold temperature slows the fermentation, which helps spread out the feedings. Water impurities are also taken into account. While these can be sensitive to impurities and chlorine, especially in the beginning, so it's best to use filtered water for the sourdough starter. When feeding the sourdough starter, once a day is fine for the first 7 to 14 days when trying to establish the colonies of good bacteria and the wild yeast. Feeding causes the bacteria and wild yeast to have insufficient time to multiply and grow. Underfeeding will cause the microbials to run out of food. Once the starter is healthy and established, there's more flexibility. Environment must be taken into for also. Cold temperatures cause the starter to take longer to get going. I live in LA, so it isn't a problem, but rides are. In a colder place, skipping a few feeding days here and there will also help fermentation. The colder it is, more lethargic the organisms will be. If it's too hot, the starter may be overrun by bad bacteria. If that happens, the mixture smells unbearable. Toss it and begin again. As shown in the video, I have a weak stomach, so in the small amount of smell overtakes me, but this does not mean the starter has gone bad. A little stink is normal. The last thing is patience. Sourdough starters are a process. I often bubble a few days into the process, but then start smelling a little funny and the bubble activity becomes inconsistent. It's fine. If you got a couple weeks and the starter isn't rising and falling on schedule, then you may have an issue with one of the factors I mentioned previously. Once the starter is established, some discard is used to make banana bread. Seeing the ingredients of the banana bread with the starter creates gluten that is held by hydrogen bonds and disulfide when mixed. Gluten is a group of proteins that are composed of the flour's gluten and gliadin proteins. During the mixing, the gluten forms sugars and starch. Amylase converts the starch to maltose, and the starter converts it to glucose, forming the flavor of the bread, the browning, and the bread's texture. During baking, the ethanol form, the yeast boils off the carbon dioxide, allows the bread to rise. The lactic acid provides some of the sour taste. The bacteria can break down the maltose, not the yeast. The baking soda is in an acidic condition, and proper hydration also produces CO2. Bitter taste. The gluten contains fats and contributes to the texture of the bread, stabilizing the bubbles and the volume of the bread. Allowing the bread to rise allows the bread to properly fill with gas and have the gluten fully form. Sourdough discard can be used for anything that can be replaced with yeast. It can also be stored in the fridge with skipping feeding days, if not going to be used often. There are a lot of factors that influence the sourdough starter, how it ferments and performs. The rate of fermentation when you need to feed it is one. There are two main components, temperature and inoculation percentage. Temperature is influenced by ambient temperature as well as the water temperature. That's why we use lukewarm water. Cold temperature equals slower fermentation, warm temperature, faster fermentation. Inoculation percentage is the percentage of mature starter you leave behind when you add the fresh flour and water for feeding. More mature starter you leave behind, faster fermentation. Less mature starter, slower ferment. Ideally for ferment in 12 to 24 hours at 100% hydration with 25% inoculation left out at 70 to 73 degrees Fahrenheit room temp. These numbers have been obtained by the baker's percentage. Observation that should be watched are the rise and fall back down. And when it falls back down, that is the optimal time to feed because all the naturally occurring yeast have been fully metabolized all of what they can from the previous feeding. So basically, they just need more food. Fresh flour and water is the food. Rise and fall indicates the starter is active. Removing the starter is important because it keeps the ferments consistent so it won't over ferment and overflow out of the container. Using a loose lid is important because a tight one causes pressure and can result in dangerous explosion, and no lid will have too much air to allow fermentation to occur. Rye flour was used because rye tends to be the most microbially active for all the flour choices, but one can replace it with any other whole grain flour. Since the starter is not capturing yeast from the air, but instead from the flour, we must use a specific type of flour. Flour that contains the necessary amount of yeast that can activate the starter. For hydration, 100% hydration sourdough starter means it's 1 part water and 1 part flour. In other words, for every gram of water, there's another gram of flour, hence the 100%. This is the easiest starter to maintain since most recipes are written with the 1-to-1 ratio. That being said, increasing or decreasing the hydration can alter the pH, which ultimately changes the flavor profile or sourness. A lower hydration, which is below 100%, meaning more flour and less water, is often used to create a thicker dough and stiffer baked good that is also more sour due to the lower pH. A higher hydration, over 100%, meaning less flour and more water, is more water and can contribute to a wetter, stickier dough that is higher pH and less sour. Thank you.